Okay, so welcome to the second part of the tutorial series, Wave in a Box. In the second section, we're going to take a look at how whitewater works. Now, I'm not going to look at the original project, just because there was just far too much data, far too many points to really get across the concepts that I need to show. So just to do something really basic here will help to illustrate all the ideas behind this and hopefully get across the information a lot easier. Also, one of the things I want to touch upon is just avoiding using the shelf tools too much, because you can get results with these shelf tools, but you're not going to understand how the data flows throughout the network. Okay, so we can select these objects, because what you got to think about, we need an object to select. We hit this tool, this automates the process, but it doesn't identify and it doesn't understand totally what's needed to be placed where, so it tends to get a bit messy. And now you might like to work that way, you might not, but for me, what I try to do is try to keep everything as simple as possible. Nothing needs to be more cluttered than it needs to be. I like to be able to see the data flow from one point to the next, just so when you're troubleshooting, you can kind of just chase things up and down the network easily and very fast. And just generally from an overview as well, it's easier to manage and organize everything. So you can zoom out and you can identify everything from a distance and then go kind of straight into where you need it to be, rather than jumping in and out of context. Okay, so you can see this setup that we've got here. I'm just going to hit play. All this is doing is it's emitting flip out of the sphere here. Okay, it's going down and we're generating flip, and we're generating the whitewater on the surface there. So all the default settings are currently kept as standard, but you can see that this network's fairly tidy. There's very few nodes here. We can kind of see where everything connects and flows to one another. I'm just going to cover a few kind of tips and tricks over creating this setup. Okay, so let's just start at the top here. So we've got a sphere here. You can see, got that. All I've done is I've converted that to a mesh, increased the frequency there. I've just moved it up in Y. That then goes straight into a flip or .NET. Okay, so we drop down in .NET. I'm just going to activate this, jump inside. Okay, good rule of thumb on here is anything that goes in the left is generally named object, anything in the right is generally named source. Okay, now we can use a flip source here. So if I just hit tab, type in flip, we've got this flip source here, and what this will do, this will allow us to kind of generate a volume for which will then be read and fed kind of into the network there. Now sometimes you might want to need this, but it is an additional step and it is generating a volume. Now if you need a really kind of high density flip source, and especially something that's changing every frame, this is going to slow down your setup, especially if you want to keep everything live like this is. So this is literally live all the way from the sphere to the flip to the whitewater, and then I'm just merging both at the bottom down there. Now, so that is one way of doing it. I've avoided using that, and you'll see if I just jump inside the flip, we're just using the standard pop source, the type of pop source that we'd use in a general particle simulation, and we're just scattering onto surface here using the first context geometry, and that's something that most people have probably used before. Now this skips the VDB process. I'm not saying that it's not needed, it's needed in some cases, but for simple situations you might not need to use it. So I thought I'd just cover that, because sometimes that's something that will help speed up and keep everything a lot quicker, especially while you're iterating. Okay, so standard settings at the moment, flip object. All I've done in here is, so in the flip object we're stripping out this original kind of SOP path here, which that's going to give us some, well, it's going to reference something that we don't need. Okay, because we're essentially sourcing from this point here. We do need to go into guides, okay, and you do need to go into particles there, and we're setting the visualization type to particles, because originally I think it's set to like sprites, which you can see there, and you can see things much better there. Okay, so we're dropping all these in and we're creating this manually, because we really do need to understand how all this kind of flows through. Okay, so because if you miss one attribute, you miss one step, you can't troubleshoot anything at any point. So let's just go back up again and just ensure that we understand everything as it kind of flows through the network. So we've got the sphere, moved it up, we're generating flip here. Okay. When it comes out of the flip, you can see it's losing the velocity color information. Now if you want to visualize that again coming out, what we can do is drop down this particle fluid surface here. I'll just activate this, okay, and you can see by default it's going to mesh the particles, but what we can do is we can just convert them to particles, and then in velocity we can just visualize that here, and it kind of brings back that kind of blue and white velocity visualization data that we need to see the particles. Okay, it helps give us a better idea of the motion as well. Okay, so I've just pulled that in. This is more just for kind of visualization purposes more than anything else. What you've got to realize is when we're kind of pulling the data out of the bottom of the flip solver, it's just giving us points. Now there's a lot of other things kind of being calculated and going on here. Now you can see I've used this DOP import fields, and even though it's independent and it's not got an input, what I like to do is just keep everything connected and close. I'll even color these the same if I need to, just because we can visually see how everything connects throughout the network. Okay, so on this DOP import field, what I'm doing is I'm just changing the preset here, so we can drop this down and I'll just choose flip fluid there. Okay, that's then going to set up some of these standard attributes that are being pulled out of the flip network. Okay, so you see we've got geometry, which is the points, we've got a velocity volume, and we've got a surface volume, which is a VDB. So if I just go on info here, you can see these here: surface volume, velocity volume, as you would expect. Okay, now the velocity volume is really important because that's going to be used to drive the whitewater. Okay, so just to give you just a basic idea of how that works. Okay, so let's just I'm just going to select this here. Okay, so just to visualize how this works, I'm just going to move over here just so we've got a clear kind of bit of space here. Okay, and we know that we've got, say, a particle, a flip particle, which is in a volume. Okay, so say this is the flip particle here, and essentially this is a velocity volume. So it's got a direction of the velocity and a magnitude of the velocity. Okay, now this volume, the velocity volume, is going to affect the whitewater. Okay, so once we've put the whitewater generated the whitewater points, those points here are going to be moved by the same velocity volume, which is this line here. Okay, so that's quite important because we need these in place to be able to move the whitewater later on. So we've covered how we import those fields back in here. So again, we're pulling out the velocity volume. We've got surface volume, which is not particularly too important for us at the moment, but we don't need to touch upon that. Okay, what that then is doing is generating a whitewater source object. Okay, so we're bringing in the points, we're bringing in the velocity volumes, and then we're going to generate these whitewater initial points based on the original flip. Now this is something that you would probably cache beforehand. You'd have a caching stage probably just after here, and then another one after you solve a kind of, further down here, or wherever you like really. Okay, but what we're going to do is we're going to cover how we generate whitewater from this. Now if I click on this object, you can see if we go into emission, we can emit these points based on curvature, acceleration, vorticity. There's lots of different controls here, and we can almost remap the speed. So if we've got emission based on speed, we can change the speed range there. We can limit by depth, so the whitewater is only generating at a certain height. There's lots of things that we can do here. Okay, so just to kind of get that point across, let's just say we've got a surface, which is kind of curved. We've got kind of breaking points on the flip. We've got these sharp points here. If we're generating by curvature, then you know, these points are going to be generated where they need to be, you know, at the top of these kind of peak points in the water where it kind of breaks. Okay, we've got acceleration, so as the water speeds up, you know, you're going to get that kind of white water bubbles and stuff, and they're going to generate there. Vorticity, okay, so you know, as we're getting this kind of like sweeping motion, we can generate points. Okay, now if we're visualizing, say, the side of the wave, then this is quite important, and we might do a separate pass and comp something like that in. Again, same with everything else. So these are just some parameters that you can play with to generate these initial points. Now if I select, let's clear this. If I select this white water object here, we'll just activate this. I'm just going to go back, hit play. You can see generating this volume. Okay, but this is not particularly, this is just generating on the frames based on these parameters, based on these rules. You know, this volume is going to be created here. Okay, now inside, this is then read inside another dot network. So we create another dot network. We're doing this manually again. Okay, we're going in and we're remembering, if you just type down white water, it's going to come up with only two options. So if you do this, like, we know we need an object, which again goes on the left. We've got a solver, you know, which goes in the middle. We don't need gravity here. We don't need gravity because these points are being vectored using the volume. Okay, so we know we've got the white water source here, which is essentially generating the initial point, and we're just going to illustrate that here by, let's just say it's generating a point on this peak. This is the white water source. Okay, then we've got this dot network, which is a simulation based on that point. Okay, so to change the color, we're then generating more points. Well, essentially this is the volume, but we're generating points based on the position of this. Okay, so then we're generating more points, okay, based on this in this location. Then there's a lot of other things being simulated where we're generating more points. They're probably breaking away from each other and then dissipating, and it kind of works from there really. But this is the foundation. So we generate the white water source first, and then we're generating the white water solver on top of that. Okay, further down here we've got this volume rasterize attributes, and you can see if I select this, it's trying to rasterize an attribute called density. Yeah, if I select this, you can see it's rasterizing the white water. Now we haven't currently set an attribute density on those points yet, and we can do, and we're doing that. So we're setting, so we've got these points here, you can see on the side. We're adding an attribute called density. Just in a simple way, we're adding an attribute, a value of 1, so the equal level of density to each one of these points. Okay, and then when it's being rasterized, essentially it's saying, okay, well, at any point that has a density of 1, we're going to rasterize into a volume, and that volume, or the density of that volume, is going to be a value of 1. Okay, now we can vary that, because if you think about it, it's like, if we're working with solid numbers, so it's either on or it's off, you know, there's no kind of gradual flow in or flow out of density. Okay, and that can kind of look like it's popping. Some situations it can look okay, but if you want to be able to control that, then we need to control that density attribute before it gets rasterized here. Okay, so on the left hand side here, you can see we've got a value, we're setting density, we're setting it just to a value of 1. On the right hand side here, we've got this switch. You can see we're doing the same thing, but what we're doing is we're remapping it based on some other attributes. Okay, so we know how old the particle is. Okay, and based on that, based on age, we can gradually fade that in over time. Okay, so let's just say, you know, we've got, I'm just going to draw this. So let's just say we've got a voxel here, and it's got a value of 1, so a density value of 1. What we can do is we can kind of gradually fade that in over time, so it becomes more and more dense, okay, as we go through. So essentially the density gets thicker and thicker as we go through time, and then it fades off again at the end. Okay, you can also see here we're setting the point density based, so we're setting, sorry, the alpha of the point based on density. Now we should just step back for a second and just take a look at this. Now, white water can be represented in different ways. Okay, the first thing we need to be able to do is generate the white water source and generate the white water, and then we can kind of, once we've got those, we can cache that, if we need to, and then we can decide if we want to render that as a volume, as you can see there, or if we want to render that as, let me just do this here, as points. Okay, or you can use a mixture of both. Okay, but the reason why we're kind of setting the point alpha here is essentially what it's going to do. So everything that we're doing on the kind of the amount of density inside each voxel, we can apply to a point-based approach, which is essentially alpha. So alpha is almost like the amount of density on a point. It's not going to be visible, and then it goes to visible at a value of 1. Density is not going to be visible at 0, but then it is visible at a value of 1. Okay, and you've got everything in between that. Okay, so we can render these as points, or we can render those as volumes. We can mix both in if we need to. Okay, but the most important thing is here we can control the look and the fade in and the fade out based on age and some of these other attributes that are being generated in these solvers at that point. Okay, so you can see we've got some switches set up here. So this switch here is set up to switch between whether we want a volume based approach to this, or we want points. Okay, so points versus volumes, and again, once this is cached here, or we've got the output of the white water solver here, we've got some different ways of setting density here. So we're setting a standardized density, a value of 1, or we're setting a custom density here, and we can kind of switch between these. Now you might want to set up different versions of these, and then you can work out which one works best, or even you can version these, and then you can go back to them if you ever need to. Okay. Another step here is we're using this kind of volume visualization, and all that's going to allow us to do is, so if I just click this, you can see the density is quite visible here, but if you couldn't see it too well and you just want to go in and you want a more denser volume just to kind of see everything a bit clearer, you can do that. So you can improve or increase the density there, and you can also play with the shadow scale here. We haven't got a light in the scene, but that's another thing you probably want to pull in some lights, and then you're going to get some shadow into this. One of the other things we'll probably cover is when we're rasterizing these attributes here, you can see we can apply velocity blur. So what that's going to do is going to look up the velocity volume that's being passed through here, and then just blur this. And it's almost going to be like, it's almost a way of applying motion blur, but it's going to apply the motion blur directly to the volume, and that might be something that you want, maybe not. And also bear in mind we can apply motion blur to these points as well, because if they're too well defined, we can kind of smooth those out a little bit. If we're going to use the points based approach, we can cluster and we can have more points in to increase the density. But one of the things you need to think about is if you're working on a really big scene, and your point count's already crazy high, then increasing that by 10 times may not be the best idea. Okay, so these are just some things to consider as well. So just as a quick overview again of what we've done, creating a sphere here. Okay, we're not using the volume source. Okay, we're using the standardized particle source. So we go into this flip here, you can see we've got the pop source there, we're using that instead. Okay, so and that pop source is then generating all the points without rasterizing the volume there. And it's going to do that really quickly. It's going to help us keep these interactive speeds quite high. Again, remember, these are just when they come out of here, they're just points. Okay, and we need to re-import those in using this dop import fields, because we need the point here, but remember we also need the velocity, volume that comes with that, and we get some other fields as well, but for this example we don't need to worry about that. The velocity, volume, is the most important. Okay, so that's pulled in at this point. What we're then going to do is we're going to generate the white water there source. Now this is not simulated, this is just going to break at certain points. So if I just scrub this here, you can see a good example is, as it hits just at the bottom, it's going to create this white water here. So we're generating this white water source here, okay, this point here, and then the solver is going to base that position and generate the white water around that in our however it needs to kind of generate things. Now you can mess with the settings, but essentially it's based on that position there. Okay, so once we've got that, we then go through some of these other attributes here. Okay, so let's drag this forwards again. We'll pick a good frame here. We've got, let's just say something like this. Just clear this out. Okay, we've got this frame. So we've got all this white water here. Now we're setting the density, and I will just consider this as as a volume for now. So we've got a volume here, and like we said before, these points here will start to fade. We probably might want to fade in over time, or we might want those to fade out over time. I'll just be able to control, the look and the style of this in post. So control the amount of white water once it's simulated, because if you think about it, if you've got really big simulation, anything you can kind of do in post to fix things is obviously a big plus, as opposed to re-simulating everything again. Okay, so remember, we're controlling whether the voxels, so this could be a volume, this point here, which would be controlled by the attribute density if it's a volume. If it's not, say if it's just a point, then we use alpha, okay, to fade the point in and off over time. Now, and those values can obviously be read in by your shaders and do all sorts of kind of things with that. We can apply motion blur to these points, or we can apply motion blur to the volumes to blur the volumes in the direction that they're moving. So we can kind of stylize things there. And just another thing as well to kind of touch upon that I did use was using some of the features inside the solver as well. So we've not really touched upon that too much, but if I say jump inside the solver, click on the white water solver here, everything's kind of left to default. One of the things you do want to do, well, will help you actually, is probably just create a null with a controller on, because you can see here, if I go in here, we've got a lot of parameters which are very much the same. So we've got particle separation, and we've got some kind of like particle radius scale, and you can see I've used a value of 0.5 for all of these, and what I'm doing is I'm copying the parameter and pasting as a relative reference, okay, and also doing that on some different areas as well. So we know we've got this flip container here, which is a box. So let's just define this box. So we've got this container here with the box that defines the bounds of this, and it's kind of keeping everything in this container. Now if we copy the parameters of this box, we can paste those to the white water solver as well. So everything, so if we need to update this, it updates everything for the white water solver as well. Okay, so some of these things need to be tied in, just so that when you're updating these parameters you don't forget later on. And it's also nice to have in just like a null with some controls on, just so you can really just update just one thing in one place. Again, so go back to some of the other settings that we have in here. Jump inside white water solver. Say you can see how I've pasted the relative reference across from the flip simulation into here. So the size and the center there, you can see again, we're copying the parameters across to the scale. But there's also we've got some other forces in here. Okay, so if we go into emission with advanced, we can apply noise in here. We can, there's lots of things we can kind of tweak. We've got forces. Okay, and we'll also go so we've got the section that's called foam. repellence is quite a nice feature, and you can kind of see what that is doing. That's essentially pushing, it's just breaking up the white water. So you see at points as it kind of flows out and settles on the surface here, you can see adding, you know, stronger values or more repellents in here will essentially create points in here, which will then start trying to repel or push the points away. And it'll start to kind of dissipate, but do it in these patches that kind of look very kind of natural, and you can kind of see them there, kind of there, and these points where it kind of everything kind of dissipates, but it dissipates like white water bubbles would on the surface. So hopefully this was helpful. I know it's not kind of based on the original project, but you know, it would have been just far too difficult to kind of navigate through that scene, and hopefully this illustrates and gets across some of the concepts and ideas and techniques that were used in the project.